Test. 1, 2, 3, 4. Welcome back to Fantastic Chemistry Podcast. My name is Pete. I am your host. Tuski is my co-host. And we are on chapter 5. Yeah. Chapter 1 through 4 so far. How you guys doing? Just check in. I hope you're doing okay. You are following me well. I'm doing just fine. Me and Tuski, we're just hanging out here and making some slides, making some video. We enjoy doing it, right? Do you think that chemistry is interesting? Do you think? Maybe some of you, right? So, chemistry is interesting to me. So I have a PhD in chemistry. So, anyway. Moving on to chapter 5, you'll learn about the chemical bonds. You probably have heard about ionic bond, covalent bond, metallic bond. We'll learn all those stuff. Okay. All right. But I would like to just start right here. So at the end of the last chapter, we talked about the octet rule. It's the heart and soul of chemistry for this course. All right. And all right, review real quick. So the octet rule saying that an atom becomes stable when its valence shell, which is the outer shell, or when the level, like level 1, 2, 3, 4, or whatever, the outer shell, the far from the nucleus, is filled. Basically, you add all electrons in it. All right. For example, helium, the outer shell can have only 2 electrons, so that's full. So it becomes stable. Neon, the outer shell, or the highest energy level is level 2. So the full is 8 electrons. 6 plus 2, that's 8. Okay. In argon, the valence shell is at level 3. And that's 6 plus 2, that's 8. And the krypton, the outer level is level 4. So 6 plus 2, also 8. Okay. So we call an octet rule because most atoms, the outer shell of the most atom can hold up to 8 electrons. That's why they become stable. And that's why we call it octet rule. Except helium, who has only 1 s orbital. So for helium, it's just 2 electrons. Okay. And we use the Lewis symbol to show the atomic symbol and its valence electron. For example, we have helium. The valence electron, there are 2 valence electrons. So we put 2 electrons like that. All right. For neon, the valence electron of neon is 8. So we do 4 pair. That's 4 lone. We call it lone pair. So there are 4 lone pairs. All right. Argon. So we got 8 electrons as well. So the valence electron. So 1, 2, 3, 4, 5, 6, 7, 8. And krypton, same thing. Okay. So we use Lewis symbol to show the valence electron of an atom. All right. And not only group A that can have 8 electrons. So other elements in other groups, they try to become stable. They're not stable yet. For example, fluorine, group 7 valence electrons. So that 5 plus 2 is 7. So fluorine try to become octet, try to get 8 electrons. Fluorine has 2 options. Either gain 1 or lose 7. That's right. And I'm sure lose 7 does take a lot of energy. So easier to just gain 1 electrons and just become helium. That's become neon. That's the electron configuration of neon. See that? That's 8 electrons and become stable. So fluorine tends to gain 1 electron, become fluoride. I'm familiar with the word, with the term. So we have fluorine, which is a 7 valence electron fluorine, and fluoride. So that's what we call 8 valence electron octet fluorine, basically. Okay. All right. Now, in case of sodium, so the valence electron of sodium is 1. 2 options, gain 7 or lose 1. Oh, lose 1 is much better. When sodium loses 1 electron, the inside become a valence shell. See that? And the insides already have 8 electrons. That's the reason why sodium tends to lose 1 electron, become a sodium ion. All right. So we're going to use this gaining or losing electron to make atoms more stable. All right. So let's look at this atom in a group. So group 7, halogen, we talked about earlier. So 7, for example, fluorine, 7 valence electron. This guy need 1 more to become octet, right? Just need 1 more. So fluorine, chlorine, bromine, iodine, and astatine usually gains 1 electron and become fluoride, chloride, bromide, iodide. Right? The negative charge right here, we call it oxidation number. So I'm going to refer to oxidation number pretty often. So when I say oxidation number, you know that's the charge on an atom, on an atomic symbol. Okay. Now let's go to group 6. How many valence electron? If you know group 6, 6 valence electron. Okay. So 6, 2 more to become octet, right? So oxygen, sulfur, selenium, tellurium, polonium usually gains 2 electrons and become octet. So the regular normal oxidation number of oxygen or the group 6 is -2, against 2 electrons, right? Group 5, 3 more to become octet, right? 3 valence electron, 3 more to become octet. So nitrogen, phosphorus, arsenic, antimony, bismuth tend to gain 3 electrons and become nitride like this. Yeah, phosphide. Okay. Now group 1, this I go back there. So group 1, for example, sodium, lithium, potassium, they already have 8 electrons inside that. And so only 1 electron. Get rid of that 1 electron easier, much easier than to gain 7 electrons. So lithium, sodium, potassium, rubidium, cesium, and francium, that's in group 1, usually loses 1 electron and becomes sodium ion, lithium ion, potassium ion, and so on. Okay. In group 2, beryllium, magnesium, calcium, strontium, barium. I'm taking only magnesium here. So 2 electron outside, right? Either gain 6 electron to become octet, or loses 2 electrons, and loses 2 electrons is much easier because there's already 8 electrons inside. Right? So this group tends to lose 2 electrons. All right, and you can guess now group 3. So either gains 5 or loses 3 electrons. Loses 3 much easier. 1, 2, and 3. Inside is already octet. All right. So boron, aluminum, gallium, indium, thallium usually loses 3 electrons. Okay. Now, what about carbon though? Carbon, silicon, germanium, tin, and lead. Group 4. Well, they're right in the middle, right? So in this case, they can do either. You will see sometimes carbon will lose 4 electrons, and other time carbon will gain 4 electrons. Depends on who it bonds to. Okay. Now, we know now that all these atoms they lose electron or gain electron to become octet. But how do they lose or gain electrons though? How? Well, they do that by forming a chemical bond. When this atom form a chemical bond, they will automatically either lose electron or gain electron. Okay, there's something influence that behavior. We will talk about that in a little bit. All right. So let's go to the next video. Talk about the chemical bond.